4.3 GCF, that's greatest common factor, and factoring by grouping. And it's so much fun. So, factoring is reverse of multiplication. It kind of is division, which is what we would say is the inverse of multiplication. But now we're looking to do it with many terms at a time. So what does it say? To factor out polynomials to find an equivalent expression that is the product of polynomials. An equivalent expression of this type is called the factorization of the polynomial. That sounds nerdy. I'm not going to talk about it anymore. But the greatest common factor, this is the first thing you should always look at when it says to factor. Because if you can, you should. Which will make usually the other types of factoring that we have much easier. So if you can take something out from each of the terms, set it aside, and then look back at what's left over. So we'll look for any greatest common factors. Of course, the first couple problems here are just focused on greatest common factors. But then after that, we'll look at the other strategy for today, factoring by grouping. So to factor it out, place the non-common factors in a set of parentheses and multiply the parentheses by the greatest common factor. But it has to be the greatest common factor for all the terms. If it's a binomial, it's got to be with the two terms. If it's trinomial, 3, and then so forth. So I like to look at just the numbers first, because usually it's going to have numbers and it's going to have letters. If it has more than one letter in the polynomial, I will look at different letters separately, because I can't factor out x's like I would y's. With y's, I should say. We've seen this before, where we say, look, you can distribute the 4 into the set of parentheses, and you can feel good about it, right? Because you can get 4x plus 12 from the multiplication, which is distribution. Now, though, what we're doing is, from something like this, I say, look, I can pull out a 5 from the 5x and the 30, but what's left over? Well, from the 5x, you'd have an x left over, and what's left over from the 30 is the 6, because really all we're doing is dividing, which is the factoring part here. So, yeah, we're just trying to find values from all the terms that we can yank out, which then becomes, in this case, right, that 5 is our greatest common factor between 5x and 30. Just like this one, if you had started with 4x plus 12, you can yank out a 4 from both of these terms and get this original expression, if you wanted to go backwards for some reason. So this one looks, it looks pretty nasty. There's some, yeah, right, there's like some big numbers in this stuff. Don't worry about the other stuff right now. Like I said, focus on one part at a time, see what you can yank out, and then that's what we will do. So let's see if this will, it's not giving me the right, let's try this. There we go. Now, why am I putting this in parentheses? Because like I said, I'm going to find common factors from all the terms and yank them out, okay? So whatever I get out of these, something's going to come out, and then whatever's left stays inside. So first, let's just focus on the numbers. I've got 20, 22, and negative 28. I will say this, usually if this first term is a negative, we'll factor out a negative no matter what. All that does is change the other signs. This one's not, so we don't have to worry about it. Now I look at these three numbers. I got 20, 22, and 28. In 990, maybe, definitely 920 though, we say, find the prime factorization of these. I'm not going to do that, but you could, yeah. So what I would recommend doing is going through your multiplication, your divisibility rules and seeing what you can divide by. Usually you're not going to get something funky like 17, right? Like this one, we say, look, you got 20, 22, and 28. I really don't care about the negative, but I have a number ending in 0, 2, and 8. They're all even at least. At least I should be able to factor out a 2, right? So what happens when I do that? And I'm going to check even after I factor this out. So I'm going to say, I'm going to factor out a 2. That means I'm dividing these each by 2. So I'd say 20 divided by 2, boom, is 10. 22 divided by the 2, that factored out, right? That's the 11, positive. And then the 28 divided by 2 is negative 14. Okay, now that's just the numerical part of it, okay? Now that I factored out a 2, which is kind of small, I would go back and check through these 10, 11, and 14. Like 10 and 14, you could factor out a 2, but 11 can't. That cancels out all factoring from here on, so for the numbers. So the numbers are done. Now that the numbers are done, Then I want to focus on just letters. I'm going to do this below because I probably should have given myself more space, but for the first term, I have a squared. For the next term, I have a cubed. And for the next one, I have a to the power of 9, which kind of looks like an a. But for all three of these terms, is there a certain number of a's that I can yank out from each of them? Yeah, 2 is the most because this one only has 2. So automatically, oh crap, I'm going to need more space with that 2. My bad. So let's set that 2 aside. But yeah, we can factor out an a squared from these, okay? So from this a squared, I used up all of them, so that one goes away. That's the first term. The second term, I just took away 2 of those, and so I'm just left with a. You can show the power of 1 if that makes you feel good inside. And then the last one, that's 9 minus 2, right? I took away 2 of them, so that's 9, a to the power of 7 now. All right, so that's my a's. Let's look at the b's then. So the first term has b to the power of 6. Next one is b to the power of 8. And then just an individual b. I think you guys are noticing the pattern even now, but this b right here, like we got 6 and 8 of these ones, that's a lot. This one only has 1, so as it turns out, I can only yank out 1 from each. I'm going to do it with each of them, right? So the first term, I just took out a b right there, so that's now b to the power of 5. The second one is 8 minus 1, so that's b to the power of 7. And then this b right here, we took out all the b's from this last term. Next up, we have c. Yeah, so that first term has c to the power of 5. That last one has c to the power of 7. You'll notice there's no c's. That's not, maybe x isn't the right thing to do there. But there's no c variables in the middle term. This means that we can't factor out. Some students are like, well, I can take out 5 c's, right? No, there's nothing you can do with that middle one. It has to be with all of them. Okay, so this, those c's, I need to put them in there, though. So c to the power of 5, and then c to the power of 7. So, yeah, this is, so the last thing we'll do here is we would check for any other forms of factoring, but I forget we haven't gone over them, so that's it. This one only has, well, we do have 3 terms. And just like that last one, I guess I won't put this one in parentheses, but I will show the parentheses below. But I'm going to just give myself a little bit more space here. And then everything that what the heck? There we go. Everything that I factor out is just going to come down here, okay? So once again, I'm going to focus on just the numbers first. You don't have to. You can do the x's first. And this one, by the way, only has x's. That's going to make it convenient. That's a 5, by the way. So we have 15, 5, and 35. Again, go through your divisibility rules. You can factor out, 5. There's nothing wrong with using your fingers. I like it.
You got whole sections of videos on your channel.
And they're fun. Just be happy I wasn't singing. So I'm going to factor out a 5 from each of these. So again, it'd be 15 divided by 5, which would be 3. That's my first term. The second term, 5 divided by 5. I'm going to show the one, but you wouldn't necessarily have to. We'll get to the x part of that. And then 35 divided by 5 is going to be positive 7. And do keep in mind, like if this was a minus sign right here, it'd just be a negative 7 right there. That's it. So that is our numbers, or the coefficients for each of these terms. Now let's look at the x's. X to the power of 6, x to the power of 4, and x to the power of 3. This one has 6, 4, and 3, so we have to be able to take the smallest amount of x's that are there, 3 of them. So I'm going to pull out 3 x's. That's multiplication, so it's x to the power of 3. And then how many x's do I have left? Well, that'd be 6 minus 3. That would give us x to the power of 3 there. 4 minus 1, which would leave me with just an individual x, which you can put the exponent of 1 if for some reason you want. And then up here, I wouldn't put x to the power of 0, just make that a phantom 1, because that's what it is. And then just kind of a quick visual check. Is there anything that we could still factor out of that? No, I don't see anything, so this is good. All right, polynomials that cannot be factored are just said to be factored completely. Yeah, that's redundant, but I think on the assignment it'll give you 2 choices, like, hey, write the factored form, or is it not factorable? And if I was you, I would just try the first one out, the second one just to see if it is, and then skip it, but don't, because I shouldn't say that out loud. When the leading coefficient is a negative number, like I've said before, if we see the leading coefficient is a negative, then we generally factor that out as a negative, but it does change the signs of all the other terms that are left over, so we will. So factoring by grouping, usually these will have 4 terms, and then we'll group them 2 terms at a time, like the first 2 and then the second 2. And then from that, we will factor out a binomial from the, I'm going to call it a coefficient, but that may not be correct. Often in order to identify a common binomial factor, we must regroup into 2 groups of 2 terms each. So again, that'd be 4 terms total. If you see 4 terms, generally that means that you're going to be factoring by grouping. Now, you'll see it too, where you'll be like, can't I just combine the like terms, which you could, but we haven't looked at factoring trinomials yet. So we're looking at factoring out 4-term polynomials. There we go. All right. Now I'm gonna do one side by side with this. Let's do it like this. Okay, so if you were to see, we'll do it like this. 3. I don't want to use the same number. Let me take that back. Let's try something else. 4x y minus 8x, right?
What are you doing?
No, I need the y on this one. Okay, so from this, I just want to focus on the y's right here, right? So you see the y's right there. You can yank out a y from each of these. I know it's not fully factored, but then you'd have 4x minus 8 right there. That's by factoring out just the y. It doesn't matter if this is a binomial right here. You can factor it out. Okay, how can we factor it out? Because this is a factor right here, and so is this one. Factor are values that are being multiplied together. So this is a factor of 3x. This is a factor of -3. So what I'm going to do, because this is usually we'd be looking at something like this after factoring from the grouping, right? Because this only has 2 terms right here. Usually you'd have 4 terms, and then usually you would have started with the 3x. Well, I guess it would have been 18x squared plus 21xy minus 18x minus 21y. Okay, that's usually what you'd start with, and then you'd factor out from the first 2 terms of 3x and then a -3. They've done some of that work for us just so we know what to expect, because we're going to see that in the next problem. But right here, just what I have, I can take this expression just like we did before, right? And I can factor out. Oh, dang it! If I had a little bit more space, I can factor out from those 2 a 6x plus 7y. Well, what's left over? Well, from the first term you got a 3x, and then from the second term you got a -3. That is all.
Is this what you recommend we do?
That's what we will do. That's what we will do. Now, I was trying to relate it with this.
That wasn't working out very well.
Yeah, sorry about that. My bad. I'm going to. Here we go. I heard a sigh right there. Yeah, but and I should have mentioned this, because you should always check these 2 binomials. You should always check whatever you have factored out just to make sure that there's no more factoring involved. Like this 6x plus 7y. All right, I mean, that's fine. It's nothing there that we can't factor out an x, and we can't factor out a 6, a 7, a 2, or a 3 from any of that stuff. So it just stays the same. But the parentheses there, the 3x minus 3, yeah, these both have 3's right there. Not x's, of course, but you could if you probably should factor out a 3 right there. And then what are you left with? Well, you got the x, and then you got the 3 divided, it's really -3 divided by 3, which is -1. And now we would call this fully factored. Yeah, so yeah, just want to put this in the video. Yeah, if you put the 3 in the front, it's the same thing. So this one, we got to do some factoring first, right? Now, usually we would look for any greatest common factor, really common factors. And it's got 12, 16, 9, and 12. The 9 is going to throw off the 16 right there. The 12s would work though. So I don't see any greatest common factors to factor out first, but it's something that you should always look for with any of these expressions, because if you can, you should. This one just doesn't have any.
Well, one.
One, yeah, thank you. One is always something you can factor out. It just doesn't help you or me or anyone else, right, with this kind of stuff. So from here, this is where we're going to group two terms at a time. And I sometimes I'll put parentheses around them like this, but just so we don't get it confused with multiplication, put a plus sign between. You don't have to, like if that's confusing you, don't worry about it, okay? But it may be good to see these because we need to factor these two terms at a time. So I'll actually just kind of use some transparent writing on this. So, all right, so let's get started here with the right marker. There we go. All right, so I'm going to factor out something from the first two terms. It's a 12xy plus 16x. Some students would actually right here start with the x's because they're like, oh, I know I can factor out an x. I'm not going to do that. I'm going to wait just because I like to start with the numbers. So I got a 12 and a 16, right? Yeah, what can we divide both these by? 4. Now, if you said 2, you'd have to go back in and refactor out another 2, but it's good to notice that you can factor out 4 from both 12 and 16. 12 divided by 4 is 3. 16 divided by 4 is 4, positive, by the way. So I'm going to show the plus sign. Then we got the x's. We have an x from both terms, so I can factor out an x from both terms, which means that neither term will have an x. And then there's just a y from the first term, so I'm just going to take it and drop it into the binomial. Now another thing, it's not a common question, but I'll address it, is, well, what if this negative 9y was over here? You could factor that out, and in fact, you would still come out with the same factorization. I don't know. I suppose no one really finds that super exciting, though. Next up, we got negative 9 and negative 12. So right here, the negative 9 being a negative tells me that I should be factoring out a negative just to start out with. I don't really care about the 12 being negative. It's the 9 that I care about because it's the first term in this binomial. So I'm going to factor out a negative, but I see that both of these are divisible by 3. So let's set up our parentheses here. So 9 divided by 3 is 3. Sorry, negative 9 divided by, really what would be negative 3 is 3. And then negative 12 divided by negative 3 would be positive 4. Now you see how, even at this point, at which I'm not finished, this other binomial usually will end up setting up exactly the same as the first binomial. Okay, so where this one is 3y plus 4, I'm really expecting this one to be 3y plus 4. Otherwise, this factorization is just kind of crap. Well, maybe it is anyways, but from the negative 9y minus 12, the first term had a y, so there it is. And now we can see that we do have matching binomials right there. And that's actually what I'm going to factor out, okay? So I'm going to take that 3y plus 4, and I'm going to factor it out. What was left over? Well, from the first term, we had 4 x's, and then a negative 3. Now, just to make sure I don't make the same mistake, right? 3y plus 4, I don't see any common factors there. 4x minus 3, nothing to factor out there too. Which usually, if you can factor out at the end, it means that there was a greatest common factor that probably existed from the beginning there, but or maybe even wasn't fully factored, perhaps back here somewhere. That's it for that one then. So we check for greatest common factor first. If there's 4 terms, we expect factoring by grouping. And then after factoring by grouping, then we check the final, in this case, 2 binomials, which is what it usually should be for any other greatest common factoring that can come out of it. All right, for this one, we got the 35x plus y plus 5 plus 7xy. Now this one, if you look at factoring this as it is by grouping, you can't factor it, right? But we know if we rearrange this, even just exchanging the y for either the 5 or the 7xy, it doesn't really matter. I, for example, though, I'm just going to switch the y and the 5. So I'm going to rewrite this. Now it's 35x plus 5 plus y plus 7xy. And from here, though, Now it's factorable. Let's see what happens when we do that, though, okay? So the first set of parentheses, I'm going to factor out, looks like we got the 35 and 5, right? So I can factor out a 5 from each of those. So 35 divided by 5 is 7. We'll keep the x. 5 divided by 5 is 1. So that's a positive 1, so I have the plus 1. And then the second set, I can factor out a positive y, but inside what it leaves me with is a 1 and then a plus 7x. Well, the two sets of parentheses, let's rewrite this one more time, which most students wouldn't do, but I'm going to do it just to be kind of thorough here. But I've got this, the first set of parentheses there, 5 times 7x plus 1. But then I'm going to add the y, but the set of parentheses that's attached to the y, I'm going to change the order of that just so we can see that the two sets of parentheses actually are the same. Now that I can see that, I'm going to factor that out, the 7x plus 1, from both of the terms, and then I'm left with, well, the two values that we factored out of those two sets of parentheses. So what is that? I've got the 5 in red, and then I've got the plus y in purple. Now, you could exchange these, right? It doesn't matter which one you put to the left, which one you put to the right. It doesn't matter. It is exactly the same, but this is still factorable. When I did this, just looking at it, I thought it was not factorable. And then since I did it in my head and I switched these two, I didn't notice in my head that 1 plus 7x was the same as 7x plus 1, which is why this is important to do on paper or by hand, just to kind of confirm that the two sets of parentheses, especially like this, right? I mean, it's kind of jacked up, but it's still doable. We do end up with the same exact values, and then that becomes factorable. So keep that in mind when you're doing these types of problems. All right, here we go. So this one, again, the first thing we want to check, is there any greatest common factors that we can take out of this one? And in addition to that, I guess even for me, I would see that first term is a negative 6x cubed. So I am going to anticipate taking out a negative just to start out with. Whether the other terms have anything in common that I can factor out as well, I don't care. I'm going to factor out a negative so I don't have to worry about that first term being negative. Now that we'll change the signs, which we'll get into, but let's look at, well, I'm going to start with the numbers, okay? So we got, again, 6, 18. I think we can make them. Yeah, it looks like it is. So 6, 18, and it's the 14, right? Like my first thought was 3 with the 6 and 18, but the 14 makes it just 2, which 6 and 18 are still divisible by 2, and same with 42. So yeah, again, I'm not just taking out a 2, though. It's a negative 2. So negative 6 divided by negative 2 would be positive 3. 18 divided by negative 2 would be negative 9. Negative 14 divided by negative 2 would be positive 7.
Does
And
it
then
have to be a negative?
Yeah, and then 42 divided by negative 2 would be negative 21. So that's just the numbers part of this. But then I see that each of the terms, this one has 3 x's, 2 x's, there's another 2 x's. And then this one has an individual x. So I can just yank out an individual x from each. So the x to the power of 3, we lost an x, so now it's x squared. The x squared lost an x, so there's an x. The 7 lost, the negative 14x squared lost an x, so there's another x. And then the last term just lost its only x. Now again, some students would say, can't we just combine these two middle terms? Yes, but you're kind of getting ahead of us, and eventually you'd probably factor that out anyways. So I'm going to keep it like this so that we can focus on factor by grouping. So the negative 2x stays with this expression, but I'm not going to worry about it right now. I'm not going to even worry about rewriting it yet. I'll get to it, but not yet. So the first set right here, let's see what we can factor out there. So I see I got a 3x, again, just the 3 and the negative 9. I can factor out a 3 from both of those. 3 divided by 3 is 1. Negative 9 divided by 3 is negative 3. But in addition to that, we got an x squared and an x, so I can actually take out an x from both. The first term would have an x. The second term, we took out its only x. So this is what I get from that, and I put the 1 there. If you didn't want to, you wouldn't have to. Now, let's focus on the next set. So again, we should get something out of this. let's start with the numbers, 7 and negative 21, so I can yank out a positive 7 from both these, divide them both by 7. 7 divided by 7 is 1. Negative 21 divided by 7 is negative 3. And you see, again, this is starting to set up already like that other binomial right there, which is, again, what we should expect. And then the x from the first term just stays with it because the other term didn't have an x to factor out. I know the negative 2x is out there. I'll still come back to it in the end, which is what I want, but I'm still... So do be careful. I mean, I think you guys have had some experience with factoring trinomials, which if you have, you can do it. But usually it's going to end up with something like this anyways. So yeah, let's continue here then. So within this set of parentheses, we can yank out a 1x minus 3. I'm going to keep it the same way. And then the other one has the 3x in green and then the positive 7 in orange. And at this point, with that extra set of parentheses, I'm just going to get rid of it just so it looks cleaner. And now I will apply the negative 2x to the work because now it's important to see that in there. So
So why